We've actually repeated this year. We practiced it. So we're going to be solving, first of all, systems of equations. So you're basically solving two equations. You're finding where they intersect or where they're equal. So you can solve by many methods, substitution, elimination, or you could use a calculator. I don't care how you solve, whatever method you choose, as long as you do it right and correctly. So every problem can be different. Every problem you might choose to solve by a different method. So I'm just going to go through and solve these by the easiest method for this problem. So I'm doing all my examples from your worksheet. So I'm going to do number 1 with you. So number 1, it says solve by, well, that says by substitution, but I don't care how you solve it, however you want. So first of all, I'm going to get both of mine in y equals mx plus b form. Does everybody see how this is linear and this is linear? Yeah. Okay. Linear means degree 1. X is degree 1. So we're going to solve by, well, I'm going to solve by substitution, but let's go ahead and get it into y equals form. So this one's good. I'm going to fix this. So I'm going to subtract 2x from both sides of the equation here. Okay, so I have y is equal to, and I'm going to rewrite it as negative 2x plus 7, mx plus b. So I have that, and I also have y is equal to this original equation, x plus 1. So now, because they're both equal to y, aren't they equal to each other? Isn't y equal to y? Yeah, so this is equal to this, so I'm going to set that up. Negative 2x plus 7 will be equal to x plus 1. Or in other words, what we're saying, guys, by setting this up is, when does negative 2x plus 7, when does this line equal this line, x plus 1? So we're finding where they intersect. However, this way we're just doing it algebraically. So now we just solve for x piece by piece. So I'm going to bring this 2x over. I'm going to add 2x to both sides. So I have 7 is equal to 3x plus 1, solving for x. Subtract 1. So I have 6 is equal to 3x. And then we'll divide both sides by 3. So x is equal to 2. Now, when we're solving systems of equations, they will ask you to put it in an xy point because you're finding the intersection between this line and this line. So that's not only an x point, it's an xy point. So it's 2 comma something, right? Can you find that something by plugging it into one of the equations? Yes. Yeah. So let's just plug it in. You can plug it into either or, you'll get the same answer. So I'm just going to plug in 2 here. So y will be equal to 2 plus 1, which is 3. So they intersect at 2 comma 3. That's where it's equal. We solved it. Questions on that? So I have this up so that I could graph it if I wanted to graph it and then just look at the intersection point. Do you want me to graph each of those and then show you that it does intersect at 2, 3? Are we all good with the algebra? You could do it that way, right? And you actually, the nice thing is, if you get it into y equals mx plus b form, you could graph it on your graphing calculator and then do second intersect and find where they intersect, and it would have done it for you. Does everybody understand what I'm saying? Okay. So next one, let's do number 4. So number 4, I would choose, it says solve by substitution, but I'm going to do, there's many different ways. You can do substitution or elimination. So with this one, maybe I'll just opt for elimination, and even substitution probably be easier, but let's go with elimination just for fun. So I'm solving, I don't care how you solve, I'm going to go ahead and solve by elimination. Because if I look at this, does everybody see how we could easily make our y's cancel out? If this was 3y, wouldn't those, or if this was positive 3y, wouldn't those y's cancel out? So I'm going to go ahead and manipulate this bottom equation to make this a 3y. So I'm going to multiply the entire equation by 3. So if I do that, I've got to distribute through to each term here. So my new equation will be 6x plus 3y is equal to negative 3. Now I'm also going to bring this down so that they're sitting right on top of each other. So we have 6x, I'm bringing this top one down. So I have 6x minus 3y is equal to negative 33. Do we have questions so far on what I'm doing? Okay, so now we can squish those together. We can combine those. We can put them together. So if you add straight down, aren't you going to get 12x? Yes. Positive 12x, and then we're going to have plus 0y, which is what we wanted, because 3y minus 3y is 0y, which is equal to negative 36, right? So we have 12x is equal to negative 36, and now we're solving for x really quickly here. questions so far? You sure? So we divide both sides by 12. So x is equal to what? 3. Negative 3, right? Where did I get what? The 3? I can't hear you, sorry. Can anyone? Sorry. No, that's a good question. I bet other people will have the same one. I just can't hear you. I'm sorry. I have bad ears right now. Did you figure it out? Are you sure? Because I bet other people have the same question. Did you ask where I got this 3?
Yeah.
This 3?
No, that's all.
You're all sure? Okay. Sorry, I really like answering questions, as you can tell. Okay, so we got x is equal to 3. But once again, we're trying to find where these two lines intersect. They're both lines. They're not in y equals mx plus b form, but they're still lines. So we're going to have negative 3, comma, question mark. Well, let's figure it out. Let's plug it into either equation. It doesn't matter. I'm just going to plug it in right here. So that's 2 times negative 3, because x is negative 3, plus y is equal to negative 1. And now we'll solve for y. So I'm going to erase this to give myself some room. So now solving for y, that is negative 6 plus y is equal to negative 1. Solving for y, algebraically, we'd add 6. So y is equal to 5, right? So our answer would be negative 3, comma 5. It's an xy point where those two lines intersect. Are we all good? Are you ready to practice on your own? Okay, I'm not going to make you do all of them. You're only doing 1 through 9. You can solve them by your method of choice. I don't care how, but you got to show your work, or else I can't help you on how you went wrong. So it says, number 20. If you want to read it off your paper, it's not so small. So there are a total of 15 apartments in 2 buildings. The difference of 2 times the number of apartments in the first building and 3 times the number of apartments in the second building is 5. Then it says, write a system of equations to represent this. So first of all, guys, with these kind of things, you have to kind of set up a little chart here to help you out. So first of all, it says there are a total of 15 apartments in 2 different buildings, right? Does everybody understand that? So I'm going to say, okay, so building 1, there's 2 buildings. Building 1, I'm going to call X. Building 2 is different, so I'm going to call building 2, I'm going to call Y. Is everybody comfortable with that? Okay, so we have 2 different things here. We have building 1 and building 2, X and Y. It says there are a total of 15 apartments in the 2 buildings. So we don't know how many building 1s and how many building 2s. But we do know those added up will be 15, right? So that's going to be my first system. X plus Y will be equal to 15 because these buildings plus these buildings will be equal to 15. It says there are a total of 15 apartments. Does everybody understand that? Okay, so then the second part says the difference means subtraction. So the difference of 2 times the number of apartments in the first building. So 2 times X, right? 2 times the number of buildings in the first. And then it says the difference, so subtraction, the number of apartments in the first building, and then 3 times the number of apartments in the second building. So 3y. That will equal 5. So that's our second system. So we have 2x minus 3y is equal to 5. Now we have a system of equations we can solve however we want. So I'm just going to get y alone, so I'll subtract x from both sides on the top equation. So I have y is equal to negative x plus 15. Now I'm going to solve by substitution. I'm going to substitute in that for y into the other function. So there's different ways of solving, obviously. So I'm going to choose substitution. So I have 2x minus 3 times y, which y we're substituting in that, negative x plus 15, is equal to 5. And now we'll solve it. So I kind of needed more room. Let me give myself a little more room here. Okay. Let's go ahead and continue solving. So that's 2 2x, and then we're distributing negative 3 into both of these, so be really careful here. So we'll have plus 3x, right? And then minus 45, negative 3 times negative x is positive 3x, negative 3 times positive 15 is negative 45 is equal to 5. Is everybody comfortable so far solving? So now we're going to combine our x's, so we have 5x. And then I'm going to have, so minus 45 is equal to 5. Solving for x, we'd add 45. So we have 5x is equal to 50. Divide both sides by 5. So x is equal to 10. So guys, wasn't 10 what we call the first apartment? So in the first apartment building, there are 10 buildings. So 10. Ding, 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 ding. So in building 1, there are 10 apartments. So didn't we also know that they add up to be 15? So how many is in building 2? 5. Good. Isn't that the question? It says, yeah. So it says, write a system of equations. Oh, and I used x and y. It said to use f and s. Does it matter the variable? No. Okay. So we're good. So we've answered A and B. We set up a system of equations, and then we solved. So we've answered A and B. So now I want you guys to try, kind of go about it the same way. Do problem number 10. So figure out what's x, figure out what's y, and then set up a system of equations based on what you're given. So when solving a system of equations, you're finding one intersection point, but when you're solving a system of inequalities, you're going to show it by graphing because there's going to be multiple answers. Okay, so you're going to show it by graphing and shade it in because there's going to be multiple answers. Because in inequalities, there's not just y equals something, right? It's like y is greater than or equal to 1. Well, if it's y is greater than or equal to 1, wouldn't that be many values? Any value greater than 1, right? So does everybody understand how when solving this one, there's going to be multiple answers? And the only way we really show it is by graphing. So let's go ahead and do that. So, number 3, it says find the whole number solutions, and we're going to do it by graphing. So, first of all, we're going to graph these. We're going to be dealing with lines. So, we have y is less than negative 2x plus 4. Remember that this is just a fancy equal sign, right? Everybody? So then we have y is less than or equal to x plus 2. Okay, so they're in y equals mx plus b form. We've got to make sure they're in y equals mx plus b so that we can graph our lines. So everybody, there's some scratch paper or there's some graphing paper on your desk if you need to follow me through this. So grab one of the graphing papers on top. Okay, here we go. So let's graph this first line. Y is less than negative 2x plus 4. So don't we have a y-intercept at 4? So we're going to go up 4. Now our slope is negative 2. So that means we go down 2 over 1. Down 2 over 1. And so on. Down 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Now don't draw in the line yet. Because it's y values less than, it's not equal to, it doesn't include the line. It does not include the line. So this is when we do a dotted line. Remember when we were graphing just one of these? So let's not, if it wasn't a system, we would just graph this on a number line, right? And since this is not equal to, it's an open circle. Same as an open circle is a dotted line. So we're going to draw in a dotted line because it's not equal to. Now I don't shade till the end because I don't want to have to erase. So we're going to shade in, eventually, in the correct spot, y is less than negative 2x plus 4. So think about it, guys. If I was to shade that in right now, wouldn't that be all this stuff below? Aren't these the y values less than that line? Okay, but we're not going to shade it in because it's got to be shaded for both of these at the same time. So now let's move on. I'm going to, in a different color, draw in this line. It's y equals mx plus b. So just, this is an equal sign right now. Just treat it like an equal sign, graph the line. We have a y-intercept of 2. Then we have a slope of positive 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. So we're drawing in our second line. Now with this one, it does include its y values less than or equal to that line. So it is equal to that line, so we have a solid line. Now, if we were going to just shade for this purple line, the second line, we're shading for y values less than. Wouldn't that be below the whole purple line? Everybody. Are you guys understanding this? Because otherwise this next part's going to be hard. Do you understand if we were to ignore the red line and shade for y values less than that line, it would be all of these y values right here. Okay, so now we've got to shade for both at the same time, because it's a system, so our solution is when both at the same time. So we want to shade for y values less than this line and less than this line, right? So isn't that below both lines at the same time? So let's look. Below the red line would be right here, right? And below the purple. Wouldn't that be just this piece? So this is where we would shade. Only right here. These guys, any of these xy points would be a solution. Any of these xy points would be a solution that fall in this shaded region. So I could say, well, there's multiple answers here. That's why we're shading it. So an answer is over 1 up 0, right? Isn't that a point? Another answer is over 0, negative 2. Another answer is over 2, down 5. Do you see how there's many answers? Okay. So what if I said, write a solution, write one solution that falls in this any system of inequalities. You could pick any point as long as it fell in that vicinity. Does everybody understand that? Okay, let's do another one. It's the shading part that gets hard for people. Okay, let's do another one. Number 4. So it says, find the whole number of solutions by graphing. So we're graphing lines. Lines have the form y equals mx plus b. So you're going to have to fix some of them. So we're solving for y on this top one. So we're going to subtract x from both sides. So I'm going to write it down here. So we have negative y is less than or equal to negative x plus 2. Is everybody good? Now this is where we have to be careful. When solving an inequality, if you divide or multiply by a negative, you have to just change the inequality sign, right? So divide both sides by negative 1. So we're going to have to change our inequality. So we have y is greater than or equal to, divide each of those by negative 1, negative x divided by negative 1 is positive x. Positive 2 divided by negative 1 is minus 2. Does everybody see how I fix the top? Yeah. Yes. Does everybody see how I fix the top? Let's fix the bottom. So we would subtract 2x. We want it in y equals mx plus b form. So we have y is, we didn't have to change the inequality, so y is less than or equal to negative 2x plus 5. So I'm putting it in mx plus b form. Now we can graph each of those and then shade accordingly. So we'll graph our first one. Y is greater than or equal to x minus 2. So we're graphing this line. Its y-intercept is negative 2. Our slope's 1. So we're going up 1 over 1. And this one is included. It says y is greater than or equal to that line. So we are going to have a solid line here. So I'm going to draw it in my solid line. So that was this top one in a different color, just so we can keep our eyes right here. I'm going to graph this line, so we're going up 5. Then our slope is negative 2, so that means you go down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1. Okay. And it's equal to as well, so we have a solid line. Okay, so now, get that far and then we'll shade, because the shading's the hardest part. Okay, so pay attention very carefully. We're shading for y on this red line. Y value is greater than. So wouldn't that be above the red line, guys? So above the red line, and at the same time, so that would be, if you're going to do all of it, it would be shading all of this. But at the same time, y value is less than or equal to the purple line. So above the red line, but below the purple line. Less than, right? Below. So if we were going to shade below the purple line, that'd be down here. So it has to be at the same time, above the red, but below the purple. So that would be all of this. But only in this vicinity here. So if I said, so once again, these are all these xy points that fall in this region are your answers. That's why there's not just one. So if I said name an xy point, you could say negative 3 up 1. You could say negative 4 up 1. You could say negative 5 up 1. You could say negative 3 up 3. Do you get what I'm saying, everybody? Okay. Do I need to do another one, or do you think you're okay? Okay, number 8. So we're graphing the line. So once again, you need it in y equals mx plus b form, which both of these ones are on number 8. So let's graph the line. Up 2 is our y-intercept on this top line, and then our slope's 1. So up 1 over 1. So the first step, you guys, like, as you can see, there's a lot of room for error. You have to be able to draw your lines correctly, then you have to be able to dotted versus solid, and then shade it right. So it's y values greater than, not equal to, so we're going to do a dotted line on this line. Because it's not including those values that fall on the line. And then we're going to graph this line, I'll do it in red. So y values less than negative x plus 1, it's already in mx plus b form, so I'm going to go up 1. Our slope's negative 1. So down 1 over 1. And then this one is included, so less than or equal to, so we will do a solid line for this one. So those points that fall right on this line are included in the shading. So now the shading part is the hardest part. Once again, we're keeping it for y values greater than x plus 2, which was our purple line. So above the purple line, and y values less than this line. This is my red line. So above the purple line and below the red line. So let's think about it. Above the purple line would be all this stuff. Below the red line would be all this stuff. So wouldn't that be this region right here? So any one of those xy points, including that solid line, will be a solution to this system. Meaning if we plugged in any of those xy values into here, it would make both statements true. Okay, I'm not going to make you do a whole lot of those because they take a lot of time. Just a sec. So these are the problems you're doing. 8 through 12, that's all you're doing. And then if you finish that, you can start on stage review. I don't know why I said page 3. Okay, so 8 through 12, that's all you're required to do. 8 through 12, I just did 8 for you. So you're literally only doing 9, 10, 11, and 12. Check your answers with me as you go. Be really careful when shading. That's the hardest part.